Welcome to the webinar today, everyone. I have 4 o'clock straight up Eastern time, so we're going to go ahead and begin so we can maximize our time here with Dr. Abe Lowe today. On the screen in front of you, you can see in the bottom half of that slide some of the instructions for Zoom. We'll do introductions in just a second, but I want to make sure everybody knows exactly where the tools are in Zoom. So if you hover over, in most cases, the bottom of your screen, you'll be able to click on the chat icon. We'll be using that chat box to collect ideas and thoughts and comments and questions throughout the webinar today. So if you have those, please feel free to enter them as we go along. Both Carla and I will be collecting them, compiling them, and then asking them at the end of the webinar today. So make sure you know where the chat box is down there. Also, you can raise your hand if you click on the participants icon. And then please make sure that you do keep your microphone muted so that we can keep the background noise down throughout the course of the webinar. Abe, do you have control of the slides right now?
I do.
You want to go ahead and go on to the next?
Sure.
Can move up a slide or two? Great, thanks. So today's webinar is called Designing Instructional Units Using the NGSS Storyline Approach to Support Student Sense-Making. And the organizers of this webinar series, myself, Aida Awad, NAGT past president, currently secretary treasurer for NAGT, Ed Roback from the American Geosciences Institute Center for Geoscience and Society, Carla McAuliffe, the NESTA executive director, Jessica Bean from UC Berkeley, John McDarris, and Andrew Havlis from CERC NAGT. I'm going to go ahead and move forward a slide. Thank you. And our presenter today will be Dr. Abe Lowe. He's with BSCS as a science educator, and I'm going to let him introduce himself in just a second here. But also remind you, we have 2 opportunities for discussion at the end of the webinar. That would be questions and comments and thoughts that you have throughout the webinar that are collected in the chat box. And then also on the webinar registration page, which is the same page that you will get a link to following the webinar that will have the archived version of both the slides and the video. There is a discussion thread set up there, so I'm sure that some of you will want to take advantage of having conversations about your thoughts and how you're going to use this or how you've been using this and what your experiences have been in that discussion thread. So that link is available to you now, but we'll also be sending that out afterwards, and it's currently in the chat box. You can go ahead and hop in there. One more slide forward, please. Just to give you a little bit of a preview of things coming up, and we'll remind you of this at the end of the webinar as well. The fall series of this 2018-2019 webinar series includes webinars in both October and November. Those are currently available for registration, so you can see the titles of them there on the slide. And emails will be coming out soon with links to them, but you can access those directly from the page. Okay, let's move on. And I'm going to go ahead and introduce Abe Lowe, who will be giving us a lot of great information. I've looked through the slides, and I'm really looking forward to hearing your discussion about the designing instructional units using the NGSS Storyline Approach to support student sense-making. Take it away, Abe.
Okay. All right. Thank you, everyone, for joining us today. Just to give you a little background, again, I am a science educator here at BSCS Science Learning. Prior to coming to BSCS, I was a middle and high school science teacher. I earned my Ph.D. at Northwestern, where I helped to develop some of the tools and processes involved in the storyline approach, and also design professional development to help teachers to use the approaches to align their instruction with the NGSS. I was also an instructional coach in a large urban district, supporting their rollout for NGSS curriculum materials. And at BSCS here, my work mostly involves using the NGSS storyline approach to design curriculum materials, as well as design tools and processes to support reflective practice and meaningful science teaching and learning in classrooms. I also must acknowledge I speak really fast when I get really excited. So in case I need to slow down, there is a slow down button that you can click as well as a reminder. So to kind of situate our discussion today, it's really important to first think about what our goals are with using and the shifts that are involved with aligning our instruction with NGSS. So you can really just see the utility for using such an approach for supporting meaningful science teaching and learning. So the first shift really involves the goal of the knowledge building work, moving from learning scientific facts to actually constructing explanatory knowledge. And that explanatory knowledge can take the form of explanatory models, which include the components, relationships, and processes that can kind of explain a set of related phenomena. And those models can be represented diagrammatically. So on the right-hand side is an example of a diagrammatic model that a student constructed trying to explain how and why they could detect an odor from a distance. That little thing on the right-hand side is the odor source. You can see the movements of the odor to the nose, and that the odor is moving in the form of particles. They're moving all random directions. So the second shift involves the role of the students in knowledge building work, that we want kids to be moving from just learning about science to actually engaging in the practices to actually actively figure things out using phenomenon-driven instruction. And the third shift involves moving from rote to more meaningful use of the practices and cross-cutting concepts. So a lot of us have used the claim evidence reasoning framework as a means to develop support explanation, the construction of explanations. But we want to move a little bit away from having kids think about two pieces of evidence, for example, and instead move to thinking about why those pieces of evidence are really important and why having sufficient evidence is more important for them to be thinking about. So we want kids to be really thinking about what they're doing and how their decisions will help them achieve their scientific goals. But in existing practice, many students and teachers often have little experience using these practices in authentic or meaningful ways, partly due to their experience that we had as teachers or as students, rather, or the lack of professional development or curriculum materials. And often science in classrooms is often seen as a disconnected set of activities that lack coherence or connection between or within activities. So kids don't necessarily understand how different activities connect from one thing to the other, or they're just driven by what the relevant topic is. So in light of these different challenges, we present the NGSS Storyline Approach as an answer to try to address this issue of coherence and shifting the role of the students in the knowledge building work. All NGSS storylines are anchored by an anchor phenomenon of some sort or a problem to solve, which explanation leverages important disciplinary core ideas. That investigation of that phenomenon is framed by some driving questions, such as how, why am I able to detect an odor from a distance, or how or why are sea levels changing? Students then have the opportunity to pose their initial ideas and questions about the phenomenon. And then those questions are the ones that actually frame the subsequent investigative activities, so that what kids figure out after answering each question incrementally builds over time and results in a desired model that can then be used to explain the anchor phenomenon. But this work isn't done alone, it's done in community with others, and is often mediated by a classroom discourse. So in terms of the goals of this webinar, because there aren't as many examples of coherent NGSS aligned curricula, this webinar is really focused on trying to build your capacity as teachers or individuals who work with teachers to think about how some of these aspects of this approach might be useful for aligning or modifying existing materials. To that end, I'll be sharing some principles and tools that could be used to design NGSS aligned curriculum using this approach, as well as some instructional routines that could be used in the classroom to support coherent classroom teaching and learning. So when we look at this, how we can begin to plan NGSS aligned units, I've kind of distilled it to 5 different steps. First is, what's the goal of your learning? What do you want kids to figure out? And then thinking about a phenomenon or problem context that can help kids be able to get to that understanding. And then to begin thinking about, so because we want students to be the individuals figuring these things out, we want to make sure we understand what ideas are kids likely to raise, what questions are they going to be thinking about that we can then use to frame instruction. We can then think about how we can take those questions and sequence them into a coherent sequence that, so through the answering of those questions will help them to be able to further understand the phenomenon. And as we construct our NGSS storylines, it's really important to think about, to build in explicit opportunities for students to monitor and revise their ideas over time. Because again, it's all about the kids. So let's start with that first goal. So how do we decide what the goal of our learning is going to be? And we turn to the NGSS and we look at those performance expectations that reflect what we want kids to be able to do and not just to know. So in the context of Earth systems, for example, one of the performance expectations for high school is to analyze geoscience data to make the claim that one change of Earth's surface can create feedbacks that cause changes to other Earth systems. You'll notice there's some pretty coloring in the performance expectations, and that's because those components of the performance expectation reflect the 3 dimensions of the NGSS. So all performance expectations begin with a practice of some sort. In this example, it's analyzing and interpreting data. And as a result of that analysis interpretation, kids should be developing understandings about how changes to Earth's surfaces can impact and cause changes in other Earth systems. And you'll notice that what we want kids to demonstrate has a combination of both the disciplinary core ideas as well as the cross-cutting concepts of stability and change. So once we kind of get the territory where we want kids to be learning, the next thing is to think about what's a good anchor phenomenon context that can help to drive students learning about those ideas. And the key kind of heuristic in there with choosing them is to think about what phenomenon would actually require kids to actually develop and use understandings of those target ideas and cross-cutting concepts. So through the process of developing that explanation, they will then develop those key understandings. So it's more of a backwards design. So there's lots of different criteria out there for helping to choose productive anchor phenomenon. But the key thing that I want to kind of highlight here in this talk is that we want to make sure this phenomenon can really motivate and sustain student interest. And I kind of distill that into the phrase, why should my kids care? And that's a question that I encourage you to always think about when planning and carrying out instruction. We want to make sure that our kids will have some ideas or questions about that phenomenon. And because of that, we want to make sure this phenomenon is complex, it's not very straightforward, that there's always something to be figured out. And also the phenomenon has to be investigatable, right? They have to be able to actually investigate their ideas and questions. We also get a lot of questions about what constitutes a phenomenon that can be used in these units, and they can take form in a variety of forms. They can be in the form of observations, like an experiment that you do in the moment. It could also be done through pictures or videos or even data sets as well. So we're now actually going to think about, so looking back at that performance expectation that I explained, that I described before, how can we actually use this performance expectation and choose a good phenomenon context for demonstrating that performance expectation? And one hint that we can always turn to, or usually turn to, in these performance expectations are these clarification statements. They often give examples of context through which they can develop these explanations. So for example, this one says you can look at climate feedbacks, such as how increases in greenhouse gases can cause a rise in global temperatures that melt glacial ice, etc. So as part of a unit that we're in collaboration with the University of California Museum of Paleontology, we're taking a unit that they've designed around sea level rise and actually using the Storyline Approach as a means to revise that unit. So here's the phenomenon that sea levels are changing around the world. We present students with a series of pictures. So for example, that first picture is in Asia. The second picture shows some examples of sea level rising outside San Francisco and also in Miami. In addition to some of that qualitative data, we also have some more quantitative data that show the relative sea level increases or decreases worldwide. So the arrows represent the amounts or the magnitude of the increase or decrease in sea levels. And then we would then encourage students to then pose their initial explanations. So once you've kind of assessed that maybe this is a pretty good phenomenon, the next step is to kind of think about how that explanation of that phenomenon could actually help you to be able to demonstrate that performance expectation. So this is a mapping exercise. So when we first look at the sea level rise phenomenon, it's caused by increased levels of greenhouse gases, which then results in increased global temperatures, which then melts glacial ice. And the water from the glacial ice melts, then moves to the oceans and contributes to sea levels. That's kind of a very abbreviated version of the explanation for sea level rise. I know there are other parts to it. But then when we look at the performance expectation, we see how this phenomenon will actually help us to get to the different aspects of the performance expectation, right? We have one chain, which is the increased levels of greenhouse gases, and how that cascading effect then has on leading to other changes observed in other aspects of the Earth system, which then is in the increased sea levels. So we've kind of talked a little about the goal of the students' learning, what kind of phenomena could be used to drive kids' learning. Now we need to think a little bit about the ideas and questions that kids are likely to pose. But why is it really important to anticipate those ideas when we're planning instruction? Remember, it's all about the kids, right? So if we want to promote those shifts in the student's knowledge building role, we need to understand, what kind of ideas and questions that we can use as a means to design instruction around. So in order to do that, we encourage you to use your student hat. So whatever student population that you'd be working with, you don that hat and you think about what ideas students are likely to raise about explaining that phenomenon. So really explicitly, what existing knowledge are kids likely to draw from? Or what other related phenomena can kids make connections to in service of explain that phenomenon? And as a result of doing that work, you're going to be thinking about what questions are kids likely to raise. Kids likely have some tentative ideas that they probably don't have some evidence around. So they might want to pose questions about that to see if their ideas are valid. But there also might be some holes in their understanding. They're like, well, I see these different parts, but I don't know how this might work. And that could be a question they might pose as well. So now it's your turn. I've been a little nervous about doing this, but I want to turn to the audience to see what questions do you think kids might raise about how and why sea levels are rising or changing. So in your chat box, if you can amuse me a little bit and just jot down a few questions that you think kids might raise about this phenomenon. Let's take another 30 seconds or so to kind of jot down some questions. Thank you all for participating. And you can even scroll through the group chat and see the scope of some of the questions that folks have raised, right? There's lots of questions about, is this happening everywhere? Some of you guys are thinking about alternative causes for what might be causing sea levels to change. For example, Heather mentioned about wind or the role that tides might play. Why is the pattern not consistent across? Is water moving towards the equator? How is water moving? Where is it coming from? Where is it going? And I think these are lots of different questions that kids are likely to raise here. So the open question here is, this is a process that we kind of went through as well when we were redesigning this unit. This is my messy handwriting, full disclosure. So on the left-hand side are some of the ideas. In this case, the unit had a different driving question at first. Will parts of the San Francisco Bay Area be underwater in 100 years? Why or why not? And we likely put some ideas that kids are likely to raise about the explanation, as well as some of the questions that we think might be derived from those ideas, or questions that might be, and you can see some overlap between some of the questions that you guys have raised, although you guys have lots of questions that make us think about how we might include some of those questions in our units. But now that you've kind of articulated some of the ideas that kids are likely to have, their initial ideas, plus the questions they might have, what do you do with them? How do you actually construct a unit around those questions? And you'll see there on the initial board, we kind of began that process. You'll see some of the questions are kind of circled. You know, this might be the first question, second question. We're gonna propose a different way of doing it that's better, we think, is to actually use sticky notes and actually write the questions that kids have on sticky notes and to begin grouping them in clumps. And then actually begin sequencing those questions in a coherent way so the answer to one question will then lead to the other, and at the aggregate whole, you'll actually have a better understanding of the anchor phenomenon. But we know as teachers that there are things that kids might not think about that we know are really important for helping to develop that understanding. So what we encourage you to think about is some additional questions that kids might need to think about is to use a different color sticky note and post them into the coherent sequence, so that you can kind of add to what kids might generate and kind of flesh out the storyline, so that you have that taken together, you have a better sense of using questions to frame instruction. We are providing this tool here, it's called the Storyline Planning Guide, that might help to structure some of the sequencing of ideas and also plan the activities that might be used in service of investigating those questions. So here's a 4-column table. The first column has the question, and these are where your kids' question, your bundle of questions might go. The activity that might be used to investigate those questions. What might kids figure out as a result of doing that activity and answering the question? And that 4th column is attending to the connected tissue. We want kids learning to be coherent from one place to the next. So this is the place for us to think about how does the activity that they are doing right now make sense in the context of what they've done previously and in terms of helping them to achieve the overall goal. So as a whole, the things in that 3rd column should incrementally build to develop a revised model for how and why the phenomenon occurs as it does. And this provides a nice check for us to think about the degree of fit between the question, the activity, and what we want kids to figure out. And this might be a place where we might need to relieve some activities that are our favorites and actually choose an activity that might be helpful for, again, in service of the broader goal for what we want to achieve. And again, that column is about that navigation aspect, which I talked about before. And also in the process of planning the storyline, you might identify that there are some additional questions or activities that you might need to include to supplement your storyline. So for example, you're going through and you might need that there's an additional idea or question that kids might pose that you might want to add an additional row. Or you might realize there's a claim or what we want kids to figure out where you think kids might need additional sources of evidence or opportunities to test those ideas. And you would then use those opportunities to supplement what's in the activity column that's linked to what they want the kids to figure out. So I've kind of talked a lot in the abstract, and I want to make this a little bit concrete by sharing the storyline that we're constructing with the University of California Museum of Paleontology, where we're looking at this mechanism of sea level rise, and we're actually designing activities to investigate that phenomenon. And we're only going to focus on the first 3 columns. We'll actually share with you the full complete planning guide. It's still a work in progress where you can see some of the aspects of that navigation part that's on the 4th column. But this will hopefully give you an idea of how this tool might be useful for us. So that first column has the anchor phenomenon and the driving question, why are sea levels changing? Kids do pose their initial ideas about that data set that you saw earlier, and kids figure out that sea levels are changing around the world and they might be rising more in coastal areas, but I don't know why. And then we have these sets of investigations. You'll see that that question there about what's the source of water that's contributing to sea level, the increases in sea level. To investigate that question, kids look at maps and they try to identify potential sources of water that might contribute to the increased sea levels. They also look at a NOAA activity, water everywhere, to analyze different sources of water that might contribute. And through those activities, kids figure out that large sources of water outside oceans is found in ice. which then motivates a series of activities and questions about the role that ice might play in sea level rise, or if it does. So they look at what's happening with ice. They look at some data sets showing land and sea like ice melts, and they realize that sea and land ice are melting at faster than historical rates, which then motivates the question, so if ice is melting, but that ice is really far away, like how is that ice possibly gonna get to the oceans? And then they do another NOAA activity, what a cycle activity, which actually looks at the natural processes of the water cycle and how that might serve as the mechanism for moving water from one place to the next. And again, you'll notice that some of the questions were bold-faced, and that's intentional. Those are the questions that we kind of come out with based upon the driving question for the phenomenon, as well as the questions, and we look at the question that kids are likely to raise themselves. We can kind of bucket those questions in that category. But you also see there's a series of questions in the storyline that are not bold-faced, and those are ones that are motivated because kids have figured something out earlier. So those are ones that they might not come with at the beginning, but will result in. So for example, they realize that ice might matter. So then now they try to figure out some investigations around that ice. But then we look at, we know that there are different kinds of ice. So we then think about, is all ice created equally, right? So are all the different, is how ice and sea and land ice melts contribute equally to sea level rise? So they do an activity where they actually investigate that using an activity from Cal Academy of Science, where they realize that land ice or glaciers melting actually contributes to sea levels increasing and not ice found in oceans. And that motivates the question about what's going on with glaciers, like how do they form, how do they melt? And that was actually an activity that we actually added based upon our storyline planning. Now, at this point, we've now figured out a significant amount of ideas about how why sea levels are rising, particularly around the role that the sources of water play, where this water might be coming from that might be contributing to sea levels increasing. This is the place where we'd have kids take what they've learned and actually revise the models they construct at the beginning. The second bend of this storyline looks at, so we had all this melting ice, what's causing it to happen? And so the kids look at analyze, interpret graphs, and they find that it's due to increased greenhouse gas emissions, that corresponds to the increased melting that might be due to global warming. But then we need to think about the mechanism by which greenhouse gas emissions might lead to increased global temperatures. And then also, is it really us? Could this be happening naturally? So the kids then investigate that, and it's us. Then they revise their models again at this point. But as you go through a storyline, you might realize that there are things that kids are not likely to think about on their own. And that so you need to actually create experiences where students realize that their model cannot fully explain the phenomenon. So for example, we just spent all this time in the sea level rise unit deciding that ice melting matters. But then when you look at the data that shows the volume of water that's increasing the sea levels, the amount that's due to ice doesn't actually add up completely, which motivates the question, what's going on? And we actually find that the increased global temperatures actually also leads to thermal expansion in water. So now through creating this experience, we've now created a need for students to actually revise their models over time. So that still maintains that coherence for kids. It's all about their learning and what they're figuring out. So we've gone through a lot of territory. We have the goal, we have the phenomenon, we have their initial ideas, we've begun sequencing them. Now we need to really create some opportunities for sense making to occur really explicitly in our storyline, where students are monitoring and revising their ideas over time. And why is this really, so we have the kids posing their initial ideas and questions, as we said before, and why is this really important? Because it helps to make visible their ideas, and because oftentimes these phenomena involve non-visible processes that they can't see for themselves. It often provides an opportunity for kids to just use their ideas that they have to try to construct a coherent explanation of some sort without the noise of other people getting involved. And also thinking about, you actually now create a product that all students can share with others and can mediate that consensus building work. Many of our kids have are quiet in whole group discussions, right? So how can you leverage those kids? But you know that every kid has had this individual sense-making time. so you know that they have something that they can offer to the whole group discussion. We also have a routine called the construction of a driving question board, where kids post their questions that they have from the very beginning on individual sticky notes. They then are involved in the process of grouping and ordering the questions in a coherent way. So you'll see that right-hand picture actually takes those questions that are in that kind of grouped mess and actually trying to order them and developing ideas for investigation. So this is a way of kind of getting kids in and on board with what you're about to do. And this creates that space for you to think about how these questions are aligned with the questions you had anticipated, and also provides the opportunity to modify potentially or reframing how particular activities. This driving question board is also a tool that can be used to support coherence for students. It creates a tool that you can revisit over time to remind kids about what we're doing and why we're doing it. And this is also a living document. So as kids are figuring things out, they can continue to add additional questions to the driving question board. We're also going to introduce a tool called an Incremental Model Tracker. This is a tool for students to use as they're engaged in their learning, for kids to document what they're figuring out over the course of investigating these particular questions and what evidence is used to support those ideas. And we also provide that fourth column there about how we represent their ideas as well. And once kids have figured out a whole bunch of different things, we take those third and fourth columns as the ideas that should be incorporated into kids' revised models. So these are opportunities for kids to put the pieces together, so to speak. And so when they revise their models, one tool that we use to support this work is the construction of a Gotta Have It checklist, which was informed by Mark Winchell's work at University of Washington, where kids take their incremental model trackers and they take stock of what ideas have they figured out that should be incorporated into the revised models, both in terms of the ideas, as also ways to represent those ideas. Now that picture that you see there is taken from a Ph.D. that we did with teachers. It's actually a combination of two different model revision moments. So the bottom picture there shows those ideas that are in that Gotta Have It checklist that were done based upon ice melting aspects, whereas the top part looks at the effect that increased greenhouse gas emissions have on contributing to the ice melting. So why is this whole process worth it? Because it takes a lot of time. It's because it offers students the opportunity to make connection between their ideas. Not only the ideas that they've learned in that particular segment of the learning, but also how they can look across what they've done. So you can see that the teacher's convenient fingers are beginning to think about the connections between the increased gas emissions and ice melting. And as you can see, it can get potentially complicated as we begin doing our investigations. And my colleagues at UCMP had developed a resource that can kind of encapsulate some of the more systemic or global connections that kids are beginning to make on the explanatory models on the left-hand side, and be able to represent those more higher level connections on that Earth scene on the right-hand side. This also creates the opportunity for both formative and summative assessment for students and for teachers. For students, it kind of gives a check about what it is that I know, what do I not know yet, what I want to figure out next. Again, that driving question board can kind of mediate that work. For teachers, you keep the pulse of where your kids are. What are kids thinking about? How are they thinking about it? As it means to kind of inform your instruction. But also, the reality is that we need to give some grades, right? But those opportunities for that grade work should account for where you are in the storyline, whether kids have sufficient opportunity to kind of wrestle with the evidence to support those ideas before we kind of put a letter to those ideas. And again, as a part of this putting the pieces together routine, we go back to the driving question board, where students gather around the driving question board, and we kind of take stock as a class. Where are we in terms of answering the driving question? What questions have we answered, and literally taking those Post-its, taking them off and replacing them with the answer, or you can nest it on top as a kind of a representation of what we've learned, but also providing, again, the opportunity for additional questions to be investigated. And you'll continue to go through this model revision opportunities multiple times throughout the storyline. And you might realize at the end there might be questions that we haven't figured out yet. and you can then decide to do those questions that might be more tangentially related. You can then have the opportunity to kind of wrestle with those questions separately. So I'm glad folks have started to put some questions. I'm kind of wrapping up here, but just to kind of take stock of where we've been, here are the 5 steps for planning an NGSS storyline. Again, these are kind of high level kind of tips or questions that can lead you through that process. But there's one thing that's in common across all those questions. It's the students. It's not about us, it's all about them and what they're learning, and that's what we're doing in service of. So in conclusion, there are some resources here for you at that tiny URL, Storyline webinar. The tools, the incremental model tracker, as well as the planning guide, the blank version is there. We will put the C-level Rise one there shortly. I also encourage you to go to the Next Gen Storyline website. Again, they're a partner in developing some of these tools. On that resource, you have some instructional storylines, both for elementary, middle, and high school, as well as some additional strategies for trying to support the construction and use of the storylines. The C-level Rise is part of a broader set of resources as part of the Understanding Global Change project that we're doing with UCMP. So if you'd like access to the C-level Rise units, just feel free to email me. We'd be happy to grant you access, as well as there's a subsequent workshop that Jessica Bean and I will be doing at NABT on learning how to use the storyline approach, particularly for helping kids to make those Earth system connections, and also about the processes of science. So here's my information. There's my email address, as well as if you're on Twitter, feel free to follow or to tweet questions. And again, I'd like to acknowledge the partners that have kind of informed the work that you heard today. So questions from everyone?
Abe, we have a question from Kathy Gill. What about student questions that you did not anticipate, but you realize are very important? How can you detour in your plans and then get them back?
I think that's one of the reasons why we do that big, that's what, so as part of planning your storyline, you're anticipating what kids' ideas are like their race. You kind of have a plan going forward, but then that also provides the context. Now that you've kind of done that work, you can see how the questions that you did that kids are now raising, how that might fit into your story that you're constructing. You can kind of make decisions in the moments when you get the particular questions, whether it's going to take, based on where you are in the storyline, whether it's a kind of a far field kind of question. In those cases, you kind of parking lot them, and then you have your chance after the class to kind of think about how you might incorporate them. Or if you think it's really a viable opportunity, you might have the kids actually wrestle with it on the spot and think about how you might pick up. With this kind of approach, you can have the cleanest storylines in the world. But again, these are designed to be responsive to students' ideas. So the planning does help you to kind of get your benchmark, your initial path going forward. But then parking lotting or thinking about how you might make decisions, that's one of the reasons why it's really important to plan in advance. Kathy, does that answer your question? Awesome. Aida, are you choosing questions?
Okay. Yeah, we've got another one.
Okay, perfect.
Well, actually, it's a little bit of statement, but I think you can make some interesting comments about it. I like the incremental model tracker. It seems that it is an opportunity for formative assessment. Students make their thinking visible, and the teacher can see if they are going in the direction of the storyline. What would you say about that statement?
I think that's right. I think it helps us to think about their interpretations. This is something that that we've developed, and we're using it in, of course, in some of the units that we're piloting right now. And we're hoping that's a tool that teachers will not use as a means to, this is what you should have figured out, but it's something that kids actually take the path of trying to make sense of, what did I figure out and what evidence do I have to support those ideas? And it's a means to kind of provide a broader conversation. Something that we've found is helpful is, again, these are all new things that we've tried, is that when we worked with teachers doing these units, to actually construct a whole class model tracker is helpful as a way of co-constructing the model tracker. So we're really explicit about what we as a classroom community are figuring out, but also creating that tool for kids to use for their individual and small group sense making.
Great.
Um,
Missy,
oh,
go ahead, Carla.
Yeah, I was going to say the same thing. So Missy Holzer is asking if the storylines have been piloted in classrooms. It sounds like that's a yes. If so, what feedback have teachers been providing?
So in terms of the sea level rise units, we are actually piloting them this year. Right now with teachers, we did a professional development with teachers last April, and they're disseminating them into their school. So we hope to be getting feedback pretty soon, but a lot of the feedback that we have generated, often from teachers who have done previous versions of this, have got some pretty positive feedback for how they can see how the tools and routines can help to support students in making those connections globally. The Next Gen Storyline team has been doing a lot of work with piloting their units and using them, and right now I know there's a big pilot going on, and the initial findings have been pretty positive. If you follow Twitter, the Next Gen Storylines on Twitter, you'll actually see some of the data that they're pulling. And it's pretty rich. The teachers are pretty good about posting their stuff in terms of what the driving question boards look like, their initial models. So it's been very positive. We've used versions of this approach in classrooms through previous middle school curriculum, and again, it has also been positive as well.
Great. I'm going to skip over Lucy's question and come back to that in just a minute because we have a little bit of a follow-up question from, I think, Steve Maddox. Do you have a sense of total classroom time? So, what are those who are piloting it finding in terms of the amount of time it's taking in the classroom for these lessons?
We haven't gotten that data back yet, so I'm not sure on that. But I know some of the different storyline units can, depending on what they are. This is definitely the unit that we presented is much smaller in scope compared to some of the storyline units that others have used. The units that we're currently designing in collaboration with the Next Gen Storyline team can be about 4 weeks of instructional time, 3 to 4 weeks. And that really focuses on about 3 days of the anchor phenomenon routine of them experiencing the phenomenon, pose their initial explanations and questions, constructing a diagram question board takes about 3 days. And so accounting for the model revision moments, which could take about 1 to 2 days, depending. So we're aiming for around that benchmark of 3 to 4 weeks.
Okay. Is it okay, Aida, for me to go back to Lucy's question?
Yeah, that's where I was going to go. Go ahead.
Yeah.
Yep.
Is it okay to let the students ask a question that doesn't support a hypothesis? For example, to investigate a common misconception?
Absolutely. I think the only way that they're going to know it's a misconception is because the only reason that you know it's a misconception is because you have the evidence to support why it's not true. So in this approach, it's really important for kids to figure that out for themselves. So again, creating that experience for kids to test their ideas so that they can have the evidence to support why one particular idea is more valid compared to another competing idea. And that's one of the rationales for this foregrounding of the figuring things out, is that the understanding that kids are going to develop at the end will be much more robust. And that's definitely supported by research that says that if kids are wrestling with the evidence that it's okay to have misconceptions on the table, hopefully by the end of the unit, that a lot of those misconceptions would have been resolved, or because they now have the experience of using evidence to dispute a particular idea.
Okay, then we've got another question from Tim. What resource do you currently recommend for teachers that give research about students' preconceptions and misconceptions when trying to anticipate student questions during unit planning? I think you might even extend that out to questions that they come up with as they're going through and doing model revisions.
Yeah, I think that I know AAAS is a resource about typical misconceptions that kids might have. I know there are a lot of knowledgeable people that are in the audience right now that might be able to add to where those are on the AAAS. But they have typical misconceptions they might have. A lot of the resources that we're developing have an explicit section in the materials that identify typical kids' ideas. Some of those misconceptions, I usually tend to stray away from using that term misconceptions, and I look at it in terms of productive or unproductive ideas, because those ideas obviously make sense for students, but they might not be productive in that particular context. But a lot of those resources are definitely included in some of the material that we are releasing. And I know the Storylines work, if you're using their units, has those resources, but if you're developing your own, definitely turn to some of the resources like AAAS or elsewhere that might have some of those typical student ideas. Thank you, Monica.
Okay, Jennifer asks, do you use NGSSphenomenon.com? If so, can you give advice on how to best integrate it with the Storyline Planning Guide?
So I think that goes to that step about trying to identify a productive phenomenon. And then there's a search tool you can use on that website that helps you that kind of identify what's the DCI that you're trying to address. The phenomena on that website take different forms. They're often in the form of like pictures or kind of little mini videos about what might be happening. So you can definitely use resources like that as far as in your planning. You would just then reference what you're doing in the story planning guide, but it would be no different than any other resource for identifying a productive phenomenon. You would do the same steps by doing that mapping between is this phenomenon appropriate?
Another question that just came in, is anyone aware of storylines that are more oriented towards chemistry for use at a department where most prefer a teacher-driven traditional approach?
Oh, one potential source is stuff from Joe Krajcek's group is looking at some of the physical sciences oriented storylines. That might be helpful in that regard. I would have to go back. I can't go on my computer right now, but to look. But I know his group has looked at some of that territory as well. That's the one that kind of comes to the top of my head right now.
Okay, we'll get the link for that and get that out to everybody too. Any other questions that you'd like to ask Abe at this point? Okay. Abe, do you want to push? Carla, did you have one?
No, I was just going to remind folks that you can continue discussing, and I think that might be on maybe the next slide.
Yeah, move up a slide there, maybe a slide or two.
I'm sorry, say it again.
You want to move forward a slide or two, Abe? There we go. Perfect. Okay.
I can give you control, I think.
That's okay. We've only got one more slide after this.
Yeah.
Okay, so the discussion forum, as we told you, is available if you want to use that short link to get to it. It's bit.ly/92018 webinar. And just a couple of things on that. You do have to have a Circ account. So if you don't have a Circ account, top right corner, you can very quickly, very easily create a Circ account. And you can also sign up for new post notifications right next to the title of the discussion thread once you're on that discussion thread page. And a couple of us will be monitoring that page for the next few days. So we'd love to see some great discussion go on there. And then as well, either today or tomorrow, you'll be getting an email, and there will be a couple of links in that email. One of the links will be to the page that has not only this discussion thread on it, but the archived version of the slides and the video of the webinar itself. But you'll also be getting a link to the evaluation survey for this particular webinar, and it really only takes a couple of minutes to fill that out, so we'd really appreciate your feedback because that is important to us as we continue to plan new webinars for this series. So please do take advantage of the discussion forum, fill out the evaluation survey, and share out the link among your communities.
We had another question or comment come in, and we still have a few more minutes. Heather is asking, your storyline surely depends on what these students have already learned in this area, but you haven't told us that.
That's right. Yeah. So we haven't. Right. So this unit that we're in the process that we're revising is started as a unit that was trying to take a whole bunch of different synthesized resources and to be able to create a coherent unit around this particular idea. I think that is designed to be tailored towards particular grade bands, which then, depending on where what grade band you're using it with, will then have different assumptions about what prior ideas that can be leveraged from these grade bands. So the current storyline right now assumes the more general ideas that they learned from previous grade bands, at least in this particular grade, about water cycling and those basic ideas about some of those basic processes. I'm trying to look back at your comment here, Heather. So you're right. So we haven't kind of foregrounded, but I think in the more finalized materials, we would kind of call out the kind of things that kids are likely to raise. And again, if you were to use our units, we would hope that you would look at what was learned before and afterwards, and we would give some also some additional guidance for how you might leverage what your kids already know, so that certain activities might need to be modified accordingly depending on what ideas you're likely to bring to the table.
I just want to make a quick note here regarding the chemistry storylines. May 2018, if you jump back to that webinar when you get to our website, Martin Schmidt gave a webinar that was just brilliant on integrating earth and space science into chemistry classes. So I'm sure you'll find a lot of ideas there. You can go back and take a look.
And also, just to go back to Heather's remark a little bit, and there's also some big ideas for differentiating based upon what you're using this unit in middle school or high school. So some of the ideas about the thermal expansion, about the particle nature of matter and what's actually happening at the molecular level during thermal expansion would be something you would address more so in high school than you would in middle school. So there's some suggestions for differentiating there as well. So.
Okay, then we have a couple more questions that are coming in here. As a bank of storyline unit plans with resources develops, will nextgenstorylines.org be vetting the units submitted by teachers to see in some way how effective they are?
That's a good question. I will ask and see if that's part of their broader endeavor. I know that there are a lot of teacher generated websites around storylines that some of that work is, but I don't know if any of them will be folded into. I know a lot of the units have been designed by teachers in collaboration with teachers, but I will ask and see if that might be something that might be possible.
Okay, great. Well, Abe, thank you. That was a very interesting webinar. I think it gave us all a lot of insight and opportunities to look at very simple tools that we can use in classrooms to really help students take ownership of the learning and be much more involved in directing where it goes and how it gets there. So thank you very much for that. Just to remind everybody, we do have 2 more webinars yet this fall, October 11th. We have a webinar that will be presented by David Randall from the American Museum of Natural History called Using the 5 Tools and Processes for Translating the NGSS into Instruction and Classroom Assessment. And then November 8th, Michael Rainey from UC Berkeley will be telling us about quickly increasing anthropogenic global warming acceptance, 5 experimentally vetted methods, and some things about the website howglobalwarmingworks.org. So please join us for those 2 emails will be coming out. Registration is currently open for those. So thank you very much to everyone who joined us today for all your questions and comments and thoughts. And we look forward to seeing that discussion continue in the discussion thread. Thank you again to Abe. Thank you to all of the conveners for this webinar, Ed Roback, Carla McAuliffe, Jessica Bean, and to the CERC staff, John and Andrew. You guys are amazing. Thanks very much, everybody. Hope you found lots of good information in this webinar, and we look forward to seeing you again next month.
All right. Thanks for everyone for coming, and don't hesitate to reach out if you ever need anything.